Thank you very much. And thank you for all the organizers for this kind invitations. It's the first time I come to Romania. And thank you for all of you to be here. And I will finish this first section with some fundamental research, the update in 2023. I apologize for all colleagues who won't be discussed in these sections because the time is short. So I select some studies that I interest in my field of research, but I will focus mainly on how the crystal-induced inflammations and how the crystal activated the production of IL-1, because we know that now you know by Leo and Pascal talk that gout-induced inflammations is mainly dependent on IL-1. So gout inflammation is an IL-1-driven disease. And the main thing is that we know how IL-1 is produced. So IL-1 is a two-step, IL-1 production is a two-step process. The first step will induce the productions of pro-IL-1. And when this pro-IL-1 will be activated by a platform of protein called inflammasome. And this platform of protein inflammasome is composed of three main proteins. The first protein is one of the inflammasome. So we have a loss of inflammasome. The main one involved in crystal-induced inflammations is the inflammasome NLRP3. And these NLRP3 proteins can be activated by a loss of stimuli. You can see here, it's just a summary of a loss of some of stimuli that can be activated NLRP3. And when NLRP3 is activated, it will recruit an adaptive proteins. The adaptive protein is called ASC. And this ASC protein is recruited via purine domain. And ASC protein has a purine domain that can be interact with the inflammasome NLRP3. And ASC had also a CARD domain that allowed to recruit the caspase-1 via these CARD and CARD interactions. When you have these activations of the NLRP3, it will gather all the ASC protein to oligomerize and to form a speck. And this speck can be observed with specific tools in the fundamental fields. And when the ASC form the specs, it will allow the pro-caspase-1 to become the caspase-1, active caspase-1. And this active caspase-1 will cleave the pro-IL-1 to the mature IL-1. And the mature IL-1 is secreted through the channel formed by gasdermin and will have the inflammatory effect. And what is interesting in this first paper is the discovery of one protein called ASC2. So it's an isoform of ASC, and we will see why this ASC2 is important. And this was discovered in this animal. You know him because of the pandemic. So what is interesting in bats is that we know that bat is resistant to a loss of virus and to a loss of bacteria. And what is also amazing is that the lifespans of bats is very long compared to its size. So bats can live 40 years. And we expected less when we observe the size, okay? And what is the mechanism of this long life span in these animals? And one of the hypotheses is that these animals can reduce the inflammatory response, reduce the stress oxidative productions, and these reductions of inflammations is healthy, so and it contributes to the increased lifespans. So what is ASC2? ASC2 is ASC protein without containing only the purine domain without the CARD domain. So it's meaning that when ASC2 is activated, it will not be able to recruit the caspase-1. And what is interesting is that ASC2, you see, is expressed in a lot of bat species, and is highly expressed in these animals. It's low in humans. Humans have also ASC2, the gene exists, but the expression is very low. The expression of ASK2 in human is very low in all tissue. And what is interesting is that when you use cellular models and you perform the transductions and you evaluated the gene expression of the ASK2, gene expressions in bats and in humans is the same level. But when you look at the protein levels, bat ASK2 protein is very high compared to human ASK2. So you have the same level of gene expression, but the protein expression is very different. So this means that there's a post-translational regulations of ASK2 in humans. And how this ASK2, what is the mechanism of this ASK2? So when we overexpress the ASK2, in fact, the ASK2, instead of forming a speck, will form a line and will interact with the ASK and prevent, in fact, the speck formations and the recruitment of caspase and the cleavage of caspase. And where these authors overexpress ASK2 in mice, and in mice there's no ASK2, so the mice didn't express this protein, but we were able, in fact, to generate a transgenic mice overexpressing ASK2, and we show here you can see that the ASK2 expression is very widespread in every innate cells. And when we assess the inflammations in this overexpressing bat ASK2 inflammation induced by the crystal injections. So we use the air pouch model, and we inject the crystal in the air pouch, and we assess the inflammations. And when we compare the wild-type mice to the overexpressing ASK2 mice, we observe that in wild-type mice, when we induce the crystal, when we inject the crystal in the air pouch, we had a loss of cells recruitment with the recruitment of neutrophils and monocytes. But in the ASK2 overexpressing mice, this inflammation is completely dampened. And so we demonstrated that overexpressions of ASK2 in mice is able to dampen the inflammation induced by crystals, but also inflammation induced by, for example, speck particles. So speck can be excreted in cells. We can isolate the speck formations, and injecting speck into the air pouch will be also able to induce the inflammations. And to summarize, in fact, this very amazing paper with silicone analysis and genetic analysis, where we are able, in fact, to identify 4 specific residues in the ASK2, in the bat ASK2 that was modified, that was mutated in the human. And when we direct mutagenesis in the ASK2 human with these 4 residues, we are able to induce the same effect, you see, when we use these cells with this human mutated ASK2. This human mutated ASK2 has the same effect than the bat ASK2. So to summarize this paper, ASK2 is universally expressed in bat and have a very high inflammasome inhibition effect, and we can imagine that we can use this ASK protein to reduce the inflammation induced in gout. Another paper is also related with the inflammasome activations. So we have, the first paper identified the ASK2 protein, that is a protein without card domain, and this one is the contrary. This is the protein that expresses only card domain without the purine domain. So this protein without purine domain cannot be recruited with ASK, but this protein will be able to compete with ASK protein. So the card-only protein, that is known COP, the COP protein will interact with purine domain, preventing the recruitment of pro-caspase-1, so preventing the activations of caspase. And we observed that, in fact, we have 4 different COP proteins in humans. And in public data, these authors show that in crystal-induced arthritis, there are 2 CARD so CART16 and CART18, the expression of these two proteins is modulated during crystal-induced arthritis. And so what we did, we perform overexpressions of these COP proteins, these 4 different COP proteins. And when we use also the same mouse model, the Airpouch model, the inflammation induced by the injection of the crystals. And when we can observe here, so when you have the red signal, the inflammation is very high, and when you don't see the signal, there's no inflammations. So when the mice are overexpressed CART16, 18, 17, or the caspase knockdown, that is the control, excuse me. So caspase 1 knockdown is the positive control of the model, and we can see that overexpression of these different COP proteins is able to reduce the inflammation induced by the MSU crystals. And this is also the reduction of these inflammations is assessed by the decrease of cell infiltrations, the decrease of IL-1 productions, and the decrease of inflammatory cytokines. And this is specific, in fact, in inflammasome-dependent cytokines. So in these different cells, where the COP protein is overexpressed, the productions of IL-1 and IL-18 is decreased. These cytokines is inflammasome-dependent, but the productions of TNF-alpha, this is an inflammatory cytokine independent of inflammasome, the productions of TNF-alpha was not modulated by the overexpressions of this protein. So meaning that for this protein, it's very specific to reduce the inflammatory cytokine dependent of the inflammasome. So these two papers highlight again the important role of the inflammasome, and we can target the inflammasome to reduce the inflammations. And this paper was discussed by Pascal earlier, so I won't be long. So just to show that in human, we can target the inflammasome to reduce the inflammation. So this is the phase 2 study, and the phase 3 study is now launched. The other paper I want to discuss is to try to understand why gout flare occur mainly in the morning. Okay, we know that, we experience that by our patients. We always told us that when I awake in the morning, I have the flare. Okay, and this study from Onjoy showed that the flare occur 2.6 more fold-time higher in the beginning of the morning, so between 4 and 8 hours. So what is the mechanism of this? Why the flare occur in the morning? There's several hypotheses. One of the hypotheses is that uric serum level have a nictiniol rhythm, and we know that the uric acid level is high in the morning. And we know also that the variations of the urate level is a promoters of inflammation and can promote the flare. The other reason is that the cortisol also have a circadian rhythm. And we know that in the morning, at 3 and 4 hours, the cortisol level is very low. It's the lowest. So we don't have the anti-inflammatory effects of the cortisol. So that's perhaps contribute to the mechanism of flare. And what is interesting in this paper is that, so the aim of the objective of the authors is to assess whether the crystals are able to regulate or to modulate the regulators of the circadian clock genes. We know that the circadian clock is modulated by several actors, but the main one is the transcription factors BMAL and clock, which form a dimer, and this dimer will activate a lot of proteins, a lot of genes, which are, for example, period and cryptochrome. And period and cryptochrome are negative regulators of the circadian clock. So BMAL and clock is activated, will activate period and cryptochrome, and period and cryptochrome will form an heterodimer, will go to the nucleus and inhibit B-mail and clock. And these inhibitions will reduce the gene expressions of the different targets. And when period and cryptochrome is degraded, it will, the inhibitions will be dampened, and B-mail and clock will be again active. So this exchange and these regulations occurred in a 20-hour cycle. So what we observe is that when we stimulated the cells, the THP1 and macrophage, MSU crystals were able to modulate and to reduce, for example, the expression and the productions of the proteins, B-mail, and also one of the regulators, negative regulator of the circadian clock is REV-ERB alpha. So MSU crystals reduce the protein expressions of these two molecules that is important for the circadian clock. So when we assess with cellular models to know whether the crystals will, by modulating this circadian clock, we're able to modulate the inflammations. So to mimic the circadian clock, what we did is to to culture the cells without serum. When we culture the cell without serum, we will synchronize all the cells in the dish. And then after that, we mimic, in fact, the day and night rhythm by stimulating during the first 12 hours the crystals, and then assess the productions of the inflammations and the inflammation cytokines, and then between 12 and 24 hours later. So what we observe is that when the crystal, the actions of the crystal in terms of the caspase-1 activations or the IL-1 productions is completely different. You see that the effect of the crystals is more important during the first phase, where normally the B-mail expressions is low. And when we're knocked down or overexpress B-mail, so the main regulators of the circadian clock, so when the B-mail is naturally low, the effect, the knockdown, the deletions of the B-mail did not affect the crystal effect, while the overexpressions will reduce the effect of the crystals. In contrary, when B-mail is naturally high, when you knock down this protein, the effect of the crystal will be enhanced. So it means that, so B-mail is, in fact, B-mail and REV-ERB alpha are two proteins that repress the inflammasome NLRP3 activations. So when you, in the normal way, in the physical conditions, normally these two proteins reduce the inflammations. When you stimulate the crystal will inhibit B-mail, okay? So it inhibits B-mail, so if the crystal reduce the expressions of the B-mail, when the cells will be more sensitive to the crystal and to the activations of the inflammasome. And this increase of sensitivity occur during the early morning period. So this result suggests that the crystals by per se can in fact modulate the sensitivity of the cells to the inflammasome activation through the circadian clock regulations. Another paper will also assess whether how or is there other factors that can initiate the flare, and these proteins come up in this work. So this protein, CA72.4, is a glycoprotein, a biomarker of a loss of cancer, and the authors have already observed and published that in Gouty patients, the concentrations of this protein is higher compared to healthy control. And in this study, where the aim of the study was to assess whether these proteins, these biomarkers, is associated or not with the inflammations. And what we observe is that the patients, the gouty patients who had the high level of these proteins had more flare, experienced more flare. And what is interesting and what is not explained, so we try to identify a lot of factors associated with the flare, so the high productions, the high concentrations of this protein, but we can also observe that the presence of tophus is also factors, clinical factors associated with the risk of flare. We will discuss this in, after the sessions. And what we observe is that, you see, what is interesting is that, in fact, during all the follow-up of the studies, the level of these proteins remain very high, while the serum urate level between the two groups is completely similar. So it means that in this paper, the serum urate level is not associated with the risk of flare. And the mechanism of this, why these proteins induce flare is not known. So for the last 5 minutes, I want just to discuss our work that we perform in collaborations with Leo and Tanya. And the aim of our studies was to identify, in fact, factors, cytokines, or metabolites that is associated with the flare, or the increase or can induce the flare. So what we did is that we performed a prospective cohort in Lariboisière Hospital that we call Gout cohort. And in this Gout cohort, in fact, we will follow the patients between at the onset of the disease, so when the patient flare, we'll have the blood collections, and when we have a new blood collections before the initiations of the ULT, and then the third one is after reaching the target of the ULT. So for one patient is its own control, and we will have the 3 time point blood collection, and we analyze this different time point blood with using the O-link technology. So in this study, we analyzed 71 patients. So 71 patients with 2 time points and 36 patients with the 3 time point. And what we observe is that, you see on this slide, we identify a lot of biomarkers that were differently expressed during the flare, the intercritical periods, and after reached treat to target serum urate level. So you can see that in this principal component analysis, that the pattern distributions of these different markers between the flare and the intercritical periods, there's a lot of overlap, but there's also a loss of protein that is only increased or decreased during the flare. And what we observe is that there are 21 proteins which were differently expressed. And the most important are these 4, RX6, TNF soluble family member 14, the colony stimulatory factors 1, and the factor of growth factors, VEGFR-A. And what we observe is that this different protein is very strongly correlated to each other, so, and especially to the CRP level. So, and we validated this result in the independent cohort from Nijmegen and also from Cluj. And when we ask, so we identify 4 main factors. IL-6 is known as a major player also in crystal-induced inflammation. This is the secondary it is dependent of IL-1 productions. So we were interested in this protein, the TNF soluble family 14. And what we observe is that in the synovial fluid, the concentrations of these proteins is very high during crystal-induced arthritis, so in gout and CPPD associated flare, compared to OA. And when we studied the expressions of the protein in the air pouch model, when we injected the crystals, urate crystals or CPP crystals the expression of these proteins is very high compared to the PBS injections. And in vitro, when we use the recombinant protein TNF solute 14, we increase, you see, the effect of the LPS and MS2 productions of IL-1, TNF, and IL-6. And in contrary, when we use an antibody against this protein, we decrease the productions of these inflammatory cytokines. And finally, where we are able to identify some genetic variants that was associated with the the capacity of production of these factors. So to summarize, how these new markers play or can involve in the microcrystal-induced inflammations. There's a lot of work to do, but we know that this protein is expressed by immune cells, especially in macrophage and neutrophils, in endothelial cells, and in fibroblasts. The synovial fluid of this protein is also increased, in fact, in other inflammatory disease, like rheumatoid arthritis and psoriatic arthritis. And these cytokines has a lot of functions. It can promote, in fact, the inflammation either directly or indirectly through the stimulations of IL-6 productions, of IL-1 productions, but also through the vascularizations, because these proteins favor the angiogenesis. And eventually, we know that these proteins is very linked to cardiovascular disease. And so perhaps the increase of this protein that we observe in gout patients is one of the factors that link to the higher risk of cardiovascular disease that we observe in gouty patients. Thank you for your attention.